Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston. Newton's third law. We want to simplify it, the law of force pairs. But first, let's have a look.
You know, Newton's third law is kind of weird. One of my Swedish college professors kind of said it this way. He said, you know, when you push on the table, in this accent, you push on the table, you know the table is pushing back. He says, is there a genie underneath the table pushing back? And there's no genie under the table pushing back. So when I push on the table pushes back with an equal and opposite force. Or here's something strange, right? If I have my shoe, right, and I'm walking down the street, I'm applying a force to the street, and the street's applying a force to me. And the law says the force will be equal and opposite. Now, just when we say opposite, we mean opposite in terms of direction and equal in terms of magnitude. So if I apply a 15 Newton force to the table is applying a 15 Newton force back to me. So down and up, by the way, in that case, where this is down and up. Or if I lean on the table, or let's say that I have I've got this thing here. I'm pushing on the whatever this is, and it's pushing back on me. So now I have a force going back and forth, equal and opposite, on my hand.
Every force is an interaction between two objects, any two objects. Thus, forces must come in pairs. If one object exerts a force on a second object, then the second object exerts a force on the first object. And here's the kicker. The forces have the same magnitude, that means they're equal, but they're opposite in terms of their directions. So let's draw some force diagrams of some different situations. So let's say we have a 100-kilogram hockey player, right? And he checks an 85-kilogram hockey player. All right, so this is the 100-kilogram guy. And then when they collide, boom, this is the 85-kilogram hockey player. Then you have a force being against this guy, actually from, remember we talked about force body diagrams, you always draw away from the guy. So this is the force, so this is 65 newtons on the big guy, and there's also going to be 65 newtons on the small guy. So these lines should be equal in length and they're opposite. Now you might say, why aren't we drawing it right here where they're actually hitting each other? Because we always draw away from that. That's how force body diagrams. Now you might realize that the 100 kilogram guy is going to move less than the 85 kilogram because, of course, we learned about that in Newton's second law. But they're going to be equal and opposite. What about this? You lean against a wall with a force of 25 Newton. I know this is going to be weird, right? So I got a wall. That's a wall. There's a wall. Trying to draw a brick wall. All right, not so good. So if you will, think about that the F, if you will, of the action is that the wall pushes back on you at 25 newtons. And you, right, you are leaning against the wall, we could look at it, and you are pushing the opposite direction. This is the F, sometimes we say reaction. The action is the wall is pushing against you, and you are pushing against the wall with the same force of 25 newtons. Weird, right? All right, as you walk, you are pushing against the ground. So let's say we've got the ground here, and you're pushing against the ground. And when you push against the ground, you're pushing against the ground, if you will. Now this is one where you're pushing against the ground. You're pushing against the ground down. Hello, down. And this is the action. And then my shoe, that's a shoe, right? It's pushing, my foot, if you will, is sending the force of reaction. They're opposite but equal. This is an up-down one. The first two were side to side. And then the Earth pulling the moon, right? So the moon is here, and then the Earth is here. And there's a force of gravity. There's a force of gravity between each of them. So this is the F reaction, and this is the action. So even they can happen over distance when they're not even touching. That's crazy weird, isn't it? So to summarize Newton's third law, for every action, there's an equal and opposite reaction in terms of the force. And I know it's strange that when I said, the table is pushing, I'm pushing on the table and the table is pushing on me. Is there a genie underneath? Yes, that's actually what happens. Newton's third law simplified. Next up, what you're going to do is you're going to learn how to practice and do some mathy parts with this to understand how this works and how that leads to how you're going to combine this with Newton's second law for acceleration. But you can do this because Houston, we don't have problems.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a